There is so much to talk about when it comes to the science on metabolic health and metabolic-based therapies that really we've been discussing this podcast for some time, and finally it's out in the world. So thank you for being here. And I want to mention that we're going to be doing frequent episodes, not just with the three of us, but also with world-renowned experts who can dive into their area of research or even maybe clinical application. We're going to be offering presentations through this podcast. And you're going to be seeing a lot of deep dives into the research and its potential in the real world. I think that's really a key important area too. And some of these episodes, you'll be able to earn continuing medical education credits as well, which is a big deal for some of you out there. But before we dive in, why don't we first introduce ourselves and a little bit about our background? Dom, would you like to kick it off?
Yeah. Dominic D'Agostino. I'm associate professor at USF, Morsani College of Medicine, also research associate at Institute for Human and Machine Cognition. And our lab has been very passionate and kind of down in the weeds on metabolic-based research, and really passionate about moving the science to application and also the educational outreach associated with that science and the application. And I'm just very excited to bring this information with my friends here to you.
My name is Angela Poff. I'm a research associate at University of South Florida. I work with Dominic there. He was my PhD mentor and postdoc mentor, and I've continued to work with him since then. And our lab really, as he mentioned, focuses on non-toxic novel methods of targeting metabolism. I have a big focus and interest in cancer metabolism specifically, and our lab also does a lot of neurological disease research as well. So we are kind of like a metabolism lab with a very broad research focus. And I'm very interested and excited about education, and that's something that I've kind of put a lot of effort towards in the past few years. Victoria and I founded Metabolic Health Initiative together, which is a organization that puts out educational content related to metabolic health. And we host the annual medical scientific conference called Metabolic Health Summit. And so this podcast is a fun kind of extension of what we've all been doing over the past, decade plus of our lives, getting information about metabolic health and therapies into the world, because we think it's very important to do so.
Absolutely. And I'm Victoria Field. I have a little bit more of an eclectic background compared to these two. Actually got my career started the first 7 years of it. I was an NBC affiliate news reporter and anchor who was simultaneously running several fitness and nutrition-based businesses alongside my husband, where we coached everything from, the person wanting to lose weight all the way to athletes, professional athletes. I later got out of television and ended up getting my pro card and competed as a professional athlete in the fitness and bodybuilding world. And around that time, met some people in the industry, the fitness world, that allowed for me to transition into cancer research. So I really wanted to do even more than what I was doing in the nutrition space and really help people on a very deep level. And so got involved in cancer research and the implementation of metabolic therapy for cancer alongside some incredible dietitians that I worked with, and really got some firsthand experience in working with cancer patients, dealing with a wide variety of different types of cancer, using the ketogenic diet as a tool, and largely using the incredible work of Dr. Dominic D'Agostino, Dr. Angela Poff here, and what they had done in the lab, and really trying to put that into the real world in a responsible way that maybe we could get some really good information on how do we move this field forward. And that's where, Angela mentioned, that's what led to us really saying, how do we take this to the next level and bring all these incredible minds together? And Metabolic Health Summit was born along with Metabolic Health Initiative. And really this podcast, as Angela had mentioned, is another effort to put this research that might not often get talked about enough, provide a loudspeaker and really start the conversation. So that's why we really truly appreciate you being here, because without you, we can't spread the word and really start an important conversation. But why the metabolic link? So that podcast name came about because we really thought a lot about sort of what is the issue at hand here. As a society, we're metabolically unhealthy. I mean, when you think big picture, I think it's 9 out of 10 people are in fact metabolically unhealthy, and more than 70% of Americans are either obese or overweight. So clearly we've got a bit of an issue here. And the evidence is showing us that there is really this tie, this common thread, this link, if you will, that's bringing all of these, that's sort of this common thread between a lot of these diseases that we're sort of seeing. You're looking at things like Alzheimer's and mental health and cancer, and all of the things that plague us today really have this common thread of metabolism. However, when it comes to the medical education side of things, there really, unfortunately, isn't a lot of nutrition-based or metabolism-based, metabolic-based therapies that are sort of a part of the discussion and medical curriculum. So that's where we said, we really need to bring this information to people, because the lay public are also looking for this information as well and really trying to find the guidance and the resources, but don't quite know who to turn to, who to trust. That's why we always we'll put evidence first, science first. Let's really have a discussion around the research that hopefully can move this field forward. But why don't we go back to the basics and discuss what is metabolic health? Everybody's throwing those words around, but let's define it and let's talk a little bit more about it.
Yeah, so I guess I'll kick off. Metabolic health can be defined a variety of different ways, but it is the major risk factor associated with cancer, neurological diseases, and cardiovascular diseases, right? So these, and if we optimize and control our diet, which is we can directly or indirectly improve metabolic health through diet, through exercise, of course, sleep and stress, and different medications too can improve and optimize metabolic health. If we can do that and get a handle on our metabolic health, then that can prevent us from early onset of age-related chronic diseases, and neurological being high on the list of things that we study, cancer and cardiovascular disease. So there are a variety of different biomarkers that we'll be talking about through our discussions here, and how to measure them, what the optimal ranges are, and different strategies that we can use through dietary interventions, and that not just the ketogenic diet, but there are a wide variety of dietary interventions, exercise, sleep, and medications like I had mentioned.
Okay, so we've got a great general definition of metabolic health, but on a molecular level, why don't we dive into metabolism and how it might be directly connected to a variety of diseases here?
Yeah, I think that's what's so fascinating, especially for me as like a basic science researcher. I am fascinated by how many mechanisms are similar on a tissue level, on a cellular level, in different tissues of like vastly different diseases. So we're talking about like chronic diseases, some of these really hallmark things that you are likely someone's going, everyone will develop one of these eventually in their lifetime, essentially. Cancer, cardiovascular disease, stroke, for example. So diseases of aging, I guess. And when you start looking at some of the similarities between these disorders, it's really striking and shows you just how important metabolism is. And I think we can kind of conceptualize it a little bit better when we think about a class of disorders that is very specifically caused by metabolic defects. So these are called inborn errors of metabolism. This is a set of rare genetic diseases that are caused by genetic mutations in metabolic enzymes. And what's really interesting to me is that a single mutation in a metabolic enzyme can cause very, very significant and diverse symptoms, including things like seizures are very common, cognitive dysfunction, motor dysfunction, just complete like physiological abnormalities. So you see, just from the perspective of a single metabolic enzyme causing widespread tissue damage and dysfunction on a whole organismal level. So, for example, something like GLUT1 deficiency syndrome. This is a disorder caused by a mutation in a glucose transporter, and these individuals have disabilities that affect them on a global scale, both cognitively, physically, seizures, and things like that. And I think that shows you how powerful metabolism is. I mean, that's a single metabolic enzyme. There's thousands of them, right? These metabolic pathways are super complex. And so
and with GLUT1, I just want to mention, even in the presence of a persistent molecular pathology that was described by Angela, with a deficiency of GLUT1, a ketogenic diet can be used to symptomatically control many of the symptoms associated with that disease. And that would be the seizures, the motor function, and even developmental delays. So even in the presence of a persistent genetic molecular pathology, you have a dietary metabolic-based intervention that can symptomatically treat it without genetically treating the gene at hand. So
and so you can kind of zoom out from there. You think about disorders that are clearly and directly caused by a very specific metabolic issue. And then zoom out to disorders that maybe at first glance, if you're not familiar with it, you wouldn't think there would be any kind of metabolic component at all. Things like neurological diseases, like seizures, epilepsy, Alzheimer's disease, for example, multiple sclerosis, stroke,
psychiatric diseases.
A great example. And so, but what's fascinating is when you look at the tissues that are being affected in these different disorders, you really see a few commonalities. Very commonly, you see mitochondrial dysfunction. Remember, guys, the mitochondria, the powerhouse of the cells, people like to say in elementary school. The mitochondria are the hub for energy production in your cells. And they don't just make energy. They also control cell life or death. They control apoptosis, which is programmed cell death, and some other really important things.
Neurotransmitters are made in the mitochondria, MAO oxidase, for example, the synthesis of the neurotransmitters used by neurons.
Absolutely. They regulate redox homeostasis. So the mitochondria are also a major site of free radical production. These are oxygen-based little molecules that play a normal part of our physiology and are normally made during energetic pathways. But if they get out of control, they can start damaging the rest of the cell and start messing up normal functionality. Oxidative stress, which is what is called when those free radicals are kind of out of control, is a huge, consistent metabolic feature of these different diseases. You see oxidative stress, you see mitochondrial dysfunction for example, in the brain cells of Alzheimer's patients. But you also see it in the tumor cells of a cancer patient. And you see it in the neurons of an epilepsy patient. So it's very fascinating that very diverse disorders have very similar characteristics associated with metabolism. Others include inflammation, chronic inflammation, elevation of some of these pro-inflammatory cytokines like TNF-alpha and IL-1 beta. You have abnormal glucose and insulin signaling is really, really common. And still in these diseases, you really wouldn't think about it, like
Alzheimer's being type 3 diabetes. So Alzheimer's disease and other neurological diseases are associated with glucose hypometabolism in many cases, whereas cancer, on the other hand, is associated with glucose hypermetabolism as defined by, an FDG PET scan. So you have a metabolic phenotype, and there's a bit of a discussion and a debate in some circles about the metabolic origin of these things. But one ubiquitous thing that we see is that there's a metabolic component that has recently gotten the attention and more attention in the last decade of looking into the metabolic component of these things.
Yeah, and all of these things, and including microbiome dysregulation, which is really coming to the forefront as being so important, I think what is most striking to me is these are all very heavily influenced by diet, exercise, lifestyle choices, and are targetable with pharmaceuticals. You can design, pharmaceuticals that target these pathways as well. And in my opinion, it's a field that is growing so rapidly because of how promising it is. And it was perhaps not given as much, thought in the past. And I think just understanding that that metabolism and metabolic dysfunction is really a common feature between all of these different disorders makes it so promising as a therapeutic target.
Yeah, it's really clear that there is this common thread that is tying everything sort of together, or metabolic link, if you will, and hence why we're here and why we're really trying to spread the message around this research, elevate the science, bring the experts together. So in addition to the three of us taking deep dives into the research, we'll also be bringing in the experts that are either in the lab or in the clinic applying this information. So it's really going to be a great, diverse podcast that explores evidence and puts the science first above all else. And I cannot wait to be on this journey with all of you, as well as you two. I think this is going to be, it's really an exciting time for our field, and really looking forward to pushing this forward in a big way. So thank you all for listening to our podcast. Make sure you follow and subscribe.